Okay, the questions we encounter in combinations and permutations often involves where we have 5 choices, then we're down a choice, then it's 4 choices, then we're down the 2 choices, we have 3 choices left. So there's a nice easy notation or shortcut notation called 5 factorial. If you look on your calculator, you'll see either a symbol like, I think most calculators have a symbol like that. So do me a favor, just type in 5 and then do what you have to do, maybe shift to get this button. What do you get when you get there? 120, perfect. Okay, so for a natural number n factorial, where you go n and then 1 less times 1 less than that, then 1 less than that, then all the way down to 3, 2, 1. This is read as n factorial. So let's calculate the following. You know this is 4 times 3 times 2 times 1, and that would be 24, right? This is 9, just plug it in your calculator. No sense us torturing ourselves if we don't have to. If you go 9 factorial, you should get 362,880. 1 factorial is equal to 1. Type in 0 factorial. What do you get? By definition. Okay, 69 factorial, you get a really, really big number, 1.711224524 times 10 to the 98. By definition. Yeah, because there's really one choice of no choice. I don't know. Yeah, or something. I don't know. I've just accepted it. It's what works. What do you get when you do 70? Yeah, your calculator can handle exponents bigger than 99. So this is math error. You can do it manually, but it, well, it would be this times 70, right? Yeah. Okay, I want to teach you something how to do this, okay? Well, do you agree that 8 factorial is equal to 8 times 7 times 6 factorial? Divided by 6 factorial, that divides out, right? And that equals 56. Sound good? Yes. Okay. Do you agree 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1? That's 8 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Well, this is the same as 8 times 7 times 6 factorial. Because 6 factorial is 6 times 5 times 4 times 3 times 2. And that's divided by 6 factorial. That equals 57. If we did this guy, it'd be 75 times 74 times 73 times 72 times 71 factorial, all over 71 factorial. Those divide out, and you now can multiply these four numbers, and you get 29170,800. Good? So let's do this guy. That's 17 times 16 times 15 factorial all over 15 factorial times 2 factorial. So that divides out. And that is 17 times 16 is 130. No. Oh yeah. 17 times 8 times 2 over 2. So, and that works out to 136. Because I'm just going to divide that out, and got 17 times 8, and it's that. Now, this expression is n plus 2 times n plus 1 times n minus 1 all the way down to 3, 2, 1. But we can just write that as what? Perfect. This is n plus 1 factorial is this, right? So n plus 1 times n all the way down to 321. It ends at 321. But I'm multiplying it by n plus 2. Isn't this one up from that guy? Why does what? Well, this, no, it's the factorial just applies to this. Yes. You would write it like, you would write it like, oh yeah. But I don't think this makes sense. This doesn't seem to me. I don't think it, I've never seen that. We don't get that complicated, yeah. Okay, do you agree this is n plus 1 times n minus 1 factorial all over, so that divides out. So this is just n squared plus n. Do you need to see that bigger? So this is n plus 1 times n minus 1 factorial all over n minus 1 factorial, right? Does that make sense? I bring it down to the denominator so I can divide out the denominators, right? And that, then we're left with n times n, so that divides out. N times n is n squared, n times 1 is n. Is that okay? Ooh. This is 2n times 2n minus 1 times 2n minus 2 factorial all over 2n minus 2 factorial. So this is going to be 2n times 2n minus 1, and that's just 4n squared minus 2n. Good? Making sense? Solve for n. Oh, you need to, when you solve for n, you have to get rid of the factorials. Yes, yeah. Get rid of the factorials. You have to get rid of it, right? So we're going to go n times n minus 1 times n minus 2 factorial equals 42 times n minus 2 factorial. We can divide both sides by n minus 2 factorial. So we are left with n squared minus n equals 42. N squared minus n minus 42 equals 0. We're going to have to factor to solve for n. So it's going to be n minus 7, n plus 6. So n can equal 7 or n can equal negative 6. But the trouble is you never have negative in your factorials. So this is not admissible. Therefore, n equals 7. I guess they would never end. They'd go to negative a million, negative 2 billion.
Factorials go to 3 to 1, they end at 1.
Yeah.
Is it like the implication that factorial is the number of ways you can choose of commuting?
Yeah, I guess
You
so.
cannot have a negative ways.
Yeah. Yeah, it wouldn't make, and negative n wouldn't make sense for us, yeah. And the rest is your time to do homework.